So, hi everyone. The paper I'm going to present is Weaponizing Data Science for Social Engineering, Automated End-to-End Spear Phishing on Twitter. So, as the name suggests, the authors of the paper built a tool that sends phishing tweets to targeted Twitter users. So, let's get into the introduction of it. So let's talk a bit about social engineering. What is social engineering? It is nothing but manipulating and tricking people to obtain their confidential information. So, and the oldest and best social engineering attack is through phishing. We all know that there are two types of phishing attacks. One is standard phishing, and the other one is spear phishing, which is nothing but a targeted phishing. So, standard phishing is mostly used to take user information, including login credentials and other sensitive information. Whereas spear phishing is a kind of spoofing attack that targets a particular association or individual looking for unauthorized access to sensitive information. Standard phishing, which is usually automated but has a very low success rate, and spear phishing, which has a much higher success rate but comes with a much higher cost. So, what's the role of data science in information security? Till the date, we have seen many applications of data science in our applications of data science or in InfoSec in our labs and assignments of this course. But the main purpose of them is to emphasize a defense from the attacks or the breaches or other cybersecurity attacks. So now, for a change, let's have a look at the data science application for the offense purpose. So this research paper presented a tool called SnapR, which is a recurrent neural network that learns user behavior based on the tweet history and post phishing tweets targeting specific users. So this is the tool. So and the SnapR is abbreviation for social network automated phishing with reconnaissance. So the tool, how the tool works. The tool splits into two phases. In the first phase, it selects a targeted Twitter user from the list, and in the second phase, it scraps a customized tweet for each and every user based on the content that they have posted in tweets and their profile summary and descriptions. So the idea behind building this tool is solely for education purpose, and this tool can be used as an example or a model for social media security awareness and social media security engagement and social engagement. So this is the presentation path for today. So we're going to talk about all these concepts that will explain the complete SnapR tool. So why is it Twitter always for machine generated content? So the Twitter has several interesting side effects that can be utilized for machine learning because short post or norm post produced by model have decreased probability of grammatical errors, nothing but colloquial syntax. Furthermore, to adapt to this constraint, links on Twitter are almost always shortened due to specific character limit of the Twitter post. This can be the shortened links can be used to obfuscate a phishing domain, increase the rate of click-throughs. Other useful quirks of Twitter include bot-friendly API for data scraping, through which we can collect all the required details for any machine learning features. So other useful quirks of Twitter include bot-friendly API for data scraping. So anything you post on Twitter, people can collect all of the hashtags and the content of the tweets and your time lags or timelines, and the Twitter discloses a large amount of personal data. These factors can all be used to generate more human-like posts and avoid suspicions. So all these factors will enable a Twitter more machine generate will enable Twitter to be a more useful platform for any machine generated content. So moving on, so let's have a look at tactics, techniques, and procedures of the snapper. The tool selects the targets based on the activity level of the user and their popularity. So basically, if the Twitter user has more followers, or if he is following more of the other accounts or the verified users, those are all the targets for these for this tool. For Twitter in particular, if you have a tweet with at the rate of mention at the beginning of it, it actually treats the tweet as a reply to other tweets. So that only followers and who follow the account can only see the tweet. So by using this, uh, you have a visibility of the phishing tweet to the person that you are targeting and to you itself. So if the Twitter account from which the phishing is being done doesn't have any followers, then only the target can see the tweet. So it is easy to know if the link that was clicked, and if the link was clicked by, they can know it was the target who clicked the link. So basically, the authors of this page of this paper emphasized about this because they want to keep a track of the links being clicked by the target, and to even evade from the Twitter detection. And the other tactic that they have used is shortening of the URL, phishing URL or the payload. And at last, they have created a program, or they have introduced a code into the tool that will post the phishing tweets at a particular active intervals of the user, which we'll be discussing further. So let's talk about the design flow. So here the tool, for the tool, first we give a list of Twitter users and the payload, and then it basically calls the machine learning models to find out if they are the target, and assuming they are, then it goes and collects their timeline to a specified depth and generates a tweet either using a Markov model or a neural network, which is LSDM, and collects the timeline. After you get the tweet, you can also say whether or not you want to schedule it or post immediately. So the first phase of this tool is of selecting the value targets. Just using the Twitter and start sending phishing links over and over again will lead to the exposure and getting banned from the Twitter due to TOS violations. So by selecting the specific users uh, as target who are likely to click on the links, the number of phishing tweets sending will be decreased, and we can easily evade the detection from the Twitter. The automated targeted discovery from a given list of users is done by using clustering models. The features for these models can be extracted easily as Twitter profiles. A lot of accessible information like personal information, historical profile post, and number of followers, images, URLs, and other data. From the Twitter, we can even access the time and the date they have posted the tweets. The now the features for this clustering model are very crucial and needs to be selected very carefully to in order to select a particular user as a target. So these features are extracted by using an API call, and the obtained targets and the obtained information is in a the JSON format, and the extracted features are the content of the description that will be like available just below your profile, and the level of engagement, followers or following, account of the age by using the hashtag my first tweet, profile default settings, graphical data, attending or planning to any larger events like black hat conferences or any other conferences. These features are the key to determine the target and when to post the twist. Even that is also considered because the active hours of user determine whether they are looking at the tweet or not. Now, the clustering algorithm. So there are different kinds of, we have seen many clustering algorithms. How did the authors choose the best model? The choice is made by by looking at the maximum average silhouette score. The silhouette score is nothing but a measure of how similar an object is to its own cluster compared to other clusters. So the authors in this paper considered two clustering algorithms. They are k-means and birch and cluster and use number of different number of clusters. And the final model with a different set of parameters has a silhouette score around 0.65. So now we'll talk about the URL shortener. So in order to hide the payload and the malicious links, URL should be shortened, and Twitter also allows the short URLs to be posted. So authors tried different URL shortener services and chose Google gvovo.gl by Google, which shorten the phishing URL. By using a Google service, the link looks legitimate and can easily gain the trust of users and can get more click-throughs. So you can see here in this picture that I have presented. This is a malicious link, and all these antivirus or anti-malicious softwares have detected that it is a malicious site. One can find the maliciousness of a link through a online service called Virus Total. And this is how shortening of the same link looks in a gvovo.gl service, and which also gives the number of click-throughs. The reconnaissance for profiling. So to design a unique tweet for each user, some profiling needs to be done to figure out the content of the tweet and when to post it. The tool collects the most frequently posted topics from the target's timeline by using bag of words, which is a topic modeling technique. These topics are used to generate a custom tweet content. Next is to figure out the target's active Twitter hours. But why is this considered? First thing is a difference in time zones, and the other is if they are not online, then they won't see the posted tweet right away. So all the recent tweet times are collected through the Twitter's API, and a histogram of tweet time frequencies is generated, which even covers the time zone differences. With obtained data, tool will automatically schedule the post for a random minute within the most frequent hour. Generated tailored tweets. Two models are used to generate a specific tweet with a user's most frequently posted content, and they are Markov models and LSDM are a recurrent neural network. So in Markov model generates tweet text word by word based on transition probabilities of word occurrences in the training set. This model reads through corpus of most recent tweets and calculates pairwise frequencies as shown in the figure. of the tokens, which are then used to generate new models. So the context of the word is not considered in this model. As the constant is not considered, the obtained output from this model will be nonsensical. Next, the training LSTM. I have just mentioned if architecture of the LSTM, but that is not what they have used. We know that the LSTM RNN is a long short-term memory recurrent neural network. So the authors have hosted it on Amazon EC2 instance and trained more than 2 million tweets with this model. LSTM remembers the context of the word and uses it when predicting the next word. This precise output comes with a price that the model requires more time and data to train. It took almost 5.5 days to train this model, which has 3 layers and about 500 units per layer. And the trade-offs between LSTM and Markov chain. So the LSTM took few days to train and on the data it has. Compared to Markov model, it took only few milliseconds to train on the data. The training data used by LSTM is more than 2 million, and Markov chain uh, considered only around thousands of tweets to be trained on. The accuracy measure here is the number of click-throughs, so there is no much significant difference in the accuracy between these models. Both these models tools are publicly available, and they have a GitHub repository where you can find the entire code of this tool. The relative disk size of LSTM is much bigger because the amount of data used by LSTM is more than the Markov model. The advantage of LSTM is generally you get a kind of deeper representation of what is meant to be posting on Twitter, like broken Twitter language with emojis, abbreviations, and whatnot. The Markov model ends up overfitting to that user. For example, consider a user posts more about football games that happen during specific seasons, and posting a phishing Twitter after the finish of the season, which is no longer relevant event, and that might raise suspicions that you are being targeted. As Markov model doesn't consider the context of the text, even after finishing of the football season, the generated phishing tweet content from the Markov model may have details about the football season, so that will affect being discovered. So this slide just describes about the language of the tweet. One of the advantage of Markov model is that they can automatically generate content in any language because they are only based on the content of the user's post but not on the context. So the tweets do not have to be in English, can be in Spanish, can be in different character sets like Russian, Chinese, or Arabic even. So here you can see some other language which I don't recognize obviously. This is a tweet generated by Markov model, and this is the phishing URL being posted. But when it comes to neural net, collect the tweets by scraping the data from the target language and retrain the model. The the LSTM is a language generic model. This approach can be applied on any other social network, and this is the so basically the Jennifer Smith user has more interest towards archaeologies, and also this is the tweet that was generated by the snapper. So when we come to the results and evaluation of the tool, authors initially tested the content generation of the tool by just posting some of the generated content to a random number of users. So they have even got response from few of the users to those auto-generated tool. So if a phishing link is clicked, the tool records the timestamp, user agent, and screen name. So this is how the authors kept track of how many click-throughs are going on with the phishing links. As a pilot experiment, authors sent 90 phishing posts to different people using hashtag called CAT. After 2 hours of the experiment, there are 17% click-through rate, and after 2 days, the click-through rate is 30%. Comparing the stats of large-scale phishing campaign with Snapper. As shown in the table, the standard mostly automated phishing has a success rate of 15 to 14% click-throughs. Standard mostly automated phishing has a success rate of 5 to 40. Sorry. A spear and highly manually phishing campaign has a success rate of 45%, and spear and fully automated phishing attack by using by using Snapper has a click-through rate of more than 30%. So when we come to conclusion of this presentation, the tool mentioned in the paper states the fact that social media is rapidly emerging as an easy target for phishing and social engineering attacks, and this tool helps to create awareness of the danger or the susceptibility of Twitter and social media in general to phishing attacks and spear phishing attacks. Snapper is entirely data driven, and we have already seen how it works using machine learning models. Author claims that there are existing frameworks such as social engineering toolkit that automate the payload of phishing process, but none that tailor the phishing message of the target. Snapper closes this gap and enables penetration testers to address larger group of targets while not compromising the quality of the spear phishing posts. So I quite liked reading this paper and going through the Snapper tool code that was available on GitHub. Their presentation, so they even have a presentation video that they presented at Black Hat. After going through all of them, the information mentioned in the paper is not sufficient at all. There are many more details to be known, which can be known by going through GitHub and the video that they have presented on. So basically, the authors didn't mention any of the architectural details in the paper, like what clustering algorithms they have used, or how many layers does the LSDM has, or how many units of each layer it has. And the other thing that bothered me is they have used only 2 clustering algorithms to choose from, but we have many more of them that they can consider. And the other one is even though they have gone through multiple URL shortener services, they have choose the one that is serviced by a Google, but which is not anymore now. So I would like to see that process to be automated, and many of the by considering multiple URL shortener services, in any case, if one of them fails or one of their services are no longer available, we can use the another one to shorten the payload, which is very important for this tool. So that's all about the critiques of my critiques of the paper, and this is the end of my presentation. Any questions?
Shreya, thank you so very much. This was an excellent presentation and a very, very interesting paper. And of course, I must note that from this point onward, our presentations and the course material are going to pivot towards the adversarial use of machine learning, or adversarial attacks on machine learning as well. And I believe this paper and this presentation provided the an excellent opportunity, or an excellent pivot towards the adversarial part of our course. Now, as usual, I do have a number of questions and seats for discussion, but I would like to hear from the class first. Does anybody have any thoughts, comments, or questions about this work? All right, I'm going to do a quick poll. Sai is asking an interesting question. Do you think social engineering is interesting now that you've read about it? And I must add that Sai is an expert in social engineering.
Yes, social engineering is very much interesting, and initially Sai has also provided me few of the social engineering resources for me to get familiar. And thank you, Sai, for that.
Sai, I wish you shared those resources with the class as well.
I'm more than
interested
happy to.
All right, so send me the links. I'll broadcast them to the class. Thank you. Now, a couple of questions that I want to pose at this point. One is the metric that this project uses to measure the performance and success of their attack or their methodology. They use click-through rates, right?
Yes, Professor.
Is this a good measure of how successful their attack has been?
I don't think so, because nowadays we have a few bots that can easily click on the links or in the of the tweets, right? So I think they can improvise the metric that they have used.
That's a very, very interesting point. So our mail server uses Barracuda to detect phishing attacks and spam. And one of the things that Barracuda and similar solutions like Proofpoint solution do is going through the link first and checking the content before passing it to you as the end user. And those could constitute or those could increment the click-through count automatically. Also, another fact to point out is even if I do click on a link and go to, for example, a login page, I don't necessarily fill out the information or provide any useful information. I may just look at the page, then look at the URL and decide that it's not relevant, and or it may be malicious, and then close it, right? However, that said, currently there are very few metrics that can be used to measure phishing or the success in phishing attacks. And the most popular one, to the extent of my knowledge, is this click-through rate. Sai, would you like to share what you mentioned in chat with the class?
Sure. So you were talking about how some services like Proofpoint or Barracuda will actually go to the websites. A lot of them will open up in like a sandbox. And if the website is accepted, it's not considered malicious based on the machine learning in the background of those services. The URLs can be rewritten so that the user on the end knows that it's been evaluated. It also helps if you train up a population to look at the URL, they can identify that this one was evaluated and accepted versus one that maybe slipped through but wasn't evaluated. And it can be another layer of protection.
Very good points. The on-shortening of URLs is a very, very useful feature that some of these phishing detection or malware detection techniques solutions provide. Lisha, you mentioned something really interesting in chat. Would you like to expand on it?
It kind of goes along the lines of the metrics of a web page, but they can collect data on like your IP addresses, what country you're coming from, just by visiting that web page. So even though you may not be actually doing anything with the page, just by loading the page and creating a session cookie, it's already collected data from you.
That's a very interesting point, and it's indeed, it has the added benefit of being true. Yes, by just visiting a page, you're putting yourselves at risk. Like, as Lisha just mentioned, it's possible that your browser is suffering from some sort of vulnerability that allows for automatic and hidden downloading of malware from by just loading the web page, right?
And that's what
Also,
Sai just commented on.
yeah, I'm sorry, Sai.
Stealing my thunder.
Sorry about that, Sai. It was my mistake. And also, whenever you visit any web page, you're providing some information to the server hosting that page, including your IP address, your browser agent, so the type of browser, the type of operating system that you're using, and so on. And these type of information can also be useful to those who want to target you. Now, Nancy is asking whether it's true even with the increased usage of virtual private networks or VPNs. Well, the information about your browser and operating system is still available even through VPNs. If you use a VPN, your IP address is going to be sort of masked. It's going to remain hidden. You're using someone else's IP address. So they may not be able to, attackers may not be able to infer much about your geographical location or the type of organization you're connecting from. Now, Sai, would you like to say what you just mentioned in chat?
Basically, what you explained, the data that may be collected if you're using VPNs might not be accurate, depends on your VPN. In some cases, if you use something like Norton VPN or CyberGhost, it may get the information from that VPN of where you're being hosted, your data, but like you had just mentioned, you'd still end up with your operating system. You may end up with the browser, language settings, depending on what they're scraping.
That's true. And Lisha, you just mentioned something really interesting and important. Would you like to share it with the class?
I said that there's still a large number of people that don't use VPNs just because, one, they can't afford them, or two, they just don't know about them. And like, we typically tend to use VPNs just because we're computer science or data science, we know better. But like my parents and a lot of other people just go browsing the internet, doing whatever without the use of VPNs.
This is really important to know as a security practitioner and a security data scientist. To boil it down to a short sentence, users are not aware of many of the tools available to them to increase their security. You should always assume that users go with the simplest and least costly solutions. Now we've strayed a bit from the main topic of this paper. Does anybody have any thoughts on the paper itself? Do you think their methodology is, first of all, accurate and reproducible, and second, useful in practice? Shreya, what are your thoughts on this?
So I think that authors have developed this tool only for the educational purpose and to let people know how the phishing is working, or what is the way that the fishers are targeting high-end users, not only through Twitter and from any other social media.
Well, that's probably true, but there's another thing that everybody in the class can can benefit from knowing. And it's the fact that if you're working for an academic institution and you want to do research that involves human subjects, you need to get an approval from something called the IRB, or the Institutional Review Board. When I came across this paper, I was really surprised because no reasonable institutional review board would approve this experiment. Why? Because it's actively targeting users on the internet, actual human beings on the internet. But in any case, I'm happy that the paper is out and the research is done so that we can make use of it. Sai, you have your hand up.
Hello, can you hear me again?
Yes.
I always lose the mute button. So, as you had mentioned earlier, I do professional social engineering. This one is really interesting because part of what I do professionally is phish people. So this, while it's could be used just to show that it's possible, also has both negative and, just like everything else, it has benign and negative opportunities that go with it. It's really interesting to see, and I'd like to see more about if people actually clicked, how frequently these fake profiles got set up and posted on their own, and if they posted on the same kind of topics around the same time, because can they be identified as being a bot? But even if not, if the same model could work towards scraping social media and then helping develop an email phishing campaign, that would be cool.
I agree. And these are all very good ideas for further research if anyone's interested. All right, so Sai, did you want to add something?
I was just going to say me because it has to do with social engineering. So.
Of course, and anyone else who's interested, they can definitely get in touch with Sai for more advice and resources on social engineering, as well as me. Very well. This is the end of our session. Shreya, thank you so very much for this wonderful presentation.
Thanks, Professor.